Hey, this is a quick intro for rigid body physics using Blender. And in order to get started here, first off, we're going to go ahead and shift add to our scene a plane, scale it up 10, and this is going to be a floor. And they're going to have the boxes actually respond to physics when I run a simulation. So I'm going to take this particular box here, I'm going to grab it, and I'm going to move it up on the z-axis above the plane. And then just so that I can see everything better, I'm going to go underneath shading here and select random for the color of each box. Now, if I already hit play right now, because I haven't done any keyframes, I haven't added any animation, nothing changes in my particular scene. But if I click on this box and then I go to the little circle with a little round, I don't know, kind of looks almost like a Bohr atom, but anyway, it's a physics tab, and then I can end up adding a rigid body to that particular box. As soon as I add rigid body to the box, next time that simulation cycles through, the box falls, which is great, but it falls right through the floor. I would like it to not fall through the floor, but it will only interact with things that have a rigid body or collision turned on to them. So I need to add rigid body to the floor. Unfortunately, as soon as I add a rigid body to the floor falls right along with the box. Not what I'm looking for. So if I move this over, the floor, which I have selected, in fact, let me call this floor, has dynamic turned on to it. That means that it's going to move according to the physics. I don't want it to move according to the physics, so I'm going to go ahead and uncheck this, which will hold it to where it is. And now I can see that the box actually falls straight onto the floor and works as needed. So in order to make the physics a little bit interesting, I can go ahead, I'm going to scrub back to keyframe 0. I'm going to take the box, going to do Shift D, duplicate it, Shift D, duplicate it, and it will also duplicate the physics that I have for these boxes. Shift D, duplicate. And when I run this, I end up with a more interesting simulation. Definitely see I got some sort of physics going on here. I can go ahead and Shift A and add additional types of meshes. Grab that circle. Whoops, I did not want to add a circle. I wanted to add a sphere. I'm going to Shift A, add a UV sphere. Grab that, move it up on the Z-axis, and again, it doesn't do anything until I turn on rigid body. But once I do that, then I've actually got a circle, and you can see here that they actually are starting in a collision format, so the circle gets a little bit of bounce to it and actually flies off to the side. So I need to go back, stop my simulation, move it to the beginning, and yeah, look, that circle is slightly colliding with the box there. So I'm going to grab that, move it off to the side. Thought it was in frame. That's weird. I seem to have turned completely upside down. There we go. Okay. As you can see, we can do some rigid body physics, fairly straightforward, and if I want to add a little bit of something to my particular project, I'm not simply left with just starting a bunch of items and letting the physics happen where they happen. I can also scrub here to the beginning of the frame. I'm going to grab one of these boxes. Yeah. And actually, I think maybe I'll add one more box. Mesh, cube. And then I'm going to grab this cube and move it up on the z-axis exactly 1. Now it's exactly on the surface. And then I'm going to grab it, move it along the y-axis. And I've got it over here. In this case, I can actually take a box, hit I, insert location, rotation, and scale. I can move the simulation forward however many frames I want. Grab the box, move it along the y-axis, hit insert, location, rotation, and scale. And now when I play this, that box is going to move from the left to the right during the simulation. Let it reset here. There you go. It doesn't collide with anything right now because I don't have any collision turned on. If I click on rigid body, unfortunately, it doesn't move anymore because then it takes over with rigid body physics. So I don't want rigid body turned on to something that I'm animating, but if I turn on collision as it moves through these different items, okay, it's not actually collision that I need. I'm going to turn off collision there. I goofed on that. I do want to turn on rigid body, but right, the cube doesn't move because it's underneath dynamic here. If I take off dynamic and select animated instead, the cube will actually move. And you can see this case, it moved quite a bit and just shoved those boxes way out of the way. But now I've got a little bulldozer action going on here. So I can basically unselect dynamic, select animated, and then use keyframes to animate exactly where I want something to go, and then it will interact with any rigid body items that are around it. One more thing, when you take a look at the physics, it might seem like everything moves kind of slow and a little bit weird, but one of the reasons for that is basically what I've got on these cubes. If I go underneath view and sidebar, I could see that the cubes are 2 meters by 2 meters by 2 meters, so it's basically 6 by 6 by 6 feet, and the mass is only like 1 kilogram. So they tend to move a little bit slow and sluggishly if you're thinking that these should move like small kid blocks. You would actually need to adjust the dimensions of the object, and then you would need to change the mass to match what it actually is. The defaults kind of work, they're okay, but they do make physics a little bit weird because we don't normally see 6 foot, 2 pound blocks of basically really light styrofoam. I think even a 6 by 6 styrofoam box would weigh more than 2 pounds. At any rate, it does seem a little bit off, so if you spend a little bit of time matching that, it's a pretty good idea. The other thing that really sometimes catches people is if you take a square like this and, one of these cubes like this and scale it, the scaling factor here changes and the dimensions change. It acts a little bit weird. I really recommend keeping the scale at 1. If you actually want to change the size of something, go ahead and go into tab on the edit mode and then scale it. And then over here on the mass side, make sure that the mass matches whatever you think it should be. So anyway, keep that in mind when you're putting stuff together. Match the dimensions with what they actually should be. Match the mass with what it should be as well, and that'll work fairly well. The other item is underneath collisions here. There are several different types of collision types. If you actually have something that's rectangular of some sort, you select the box collision, it will work faster than the default convex hull. The sphere will not only work faster, along with the capsule, cylinder, and cone. It will not only work faster, but it'll actually work a little bit more accurately because by default, icospheres and isospheres basically have, or UV spheres have those like little ridges in them, and you won't see those ridges when you select this. It assumes a perfectly smooth surface. Convex hull, if you don't remember convex versus concave, convex basically means it's got some sort of, it doesn't have any sort of cavity in it. Concave means like a bowl. It could actually have a cavity on it. So if you were to model a bowl and try to toss these different squares into the bowl, it wouldn't work because this collider right here assumes that there are no cavities and will fill in any cavities that happen to exist. A mesh collider does not assume those cavities. It will work for something shaped like a bowl, but it is really slow. You just kind of need to think about basically a speed trade-off. These are pretty darn fast if you are working with simple shapes. This is slower, but reasonably fast and works for most shapes. This, if you've got some sort of cavity, you're going to need to select like a bowl, something concave, then you'll need to grab that one. And that's about it for rigid body physics.